So here we're looking at a 200 kilogram crate. It's pretty heavy, 440 pounds, hanging from a chain. We want to know how much tension the chain needs to be able to withstand to lift this thing up at a constant speed. So we have the chain, we have the winch that's pulling on the chain on the other side, we have the crate or box, we have the earth, so a weight interaction for the box. The chain we'll call massless. It doesn't matter anyway, we only care about box interactions. The chain's exerting tension on the box and on the winch, and vice versa. There's some other interactions with the winch, but we only care about the box, so we'll stop once we have all the box interactions. So the box is our system, our free body diagram, and what we want is for the box to go upward at constant speed. And constant speed tells me CVPM, and CVPM tells me that the forces are balanced because the acceleration equals 0. So if I call up positive, then T minus mg is my F net equation, and the forces are balanced, so that's 0. So the tension in the chain is equal to the weight of the crate, which is 200 kilograms times 10 newtons per kilogram, or 2,000 newtons. So that's our first one. But if we're accelerating up at a rate of 1.2 meters per second squared, my system schema stays the same, but my free body diagram changes. The weight's always the same here. A little bit longer. Okay, the weight's always the same because the m and the g didn't change, but the tension has to increase in order to accelerate this thing upward. My F net equation looks really similar. T up, mg down, but the forces are not balanced this time. They're equal to the mass times the acceleration. So the tension we still don't know. I know it's a 200 kilogram crate, so I can put some numbers in for the weight. I know it's 200 kilograms, and I know the upward acceleration is 1.2 meters per second squared. Because the acceleration is up, that's in the positive direction, so I use the positive number here. And I solve. This is 200 newtons. Move it over to the other side. And this is 240 newtons. So, I'm sorry. Missing a 0 here. This one is 2,000 newtons, plus this one is 240 newtons. And my tension, therefore, is 2,240 newtons. So I definitely need some more tension to lift this thing up if I'm going to accelerate it than I do to raise it at constant speed. If I exerted less than 2,000 newtons, even if it's going up, it would be accelerating down, which means it would slow down and at some point change direction and start moving downward.